Hello everyone, welcome you all to the post content discussion of the LeetCode contest. Today we will be discussing the problem A and B. So today contest is slight harder side. Let's start with the question number A. So that is best time to buy and sell stock using strategy. You are given two integer arrays, prices and strategy, where price of I is the price of the given stock on the ith day, where strategy of I represent the trading action on the ith day, where -1 indicates buying 1 unit of the stock, 0 indicates holding the stock, 1 indicates selling 1 unit of the stock. So you are also given an even integer k may perform at most one modification. You can perform 0 operations also. And yeah, select exactly k consecutive elements in strategy. It's nothing but selecting k size subarray consecutively, and set first k by 2 elements to 0, that is indicating hold, and set last k by 2 elements to the 1. First half should be modified to elements to modify to 0, and we will set next half elements should be 1. So the profit is defined as sum of the strategy of I into profit of I across all days, right? So return the maximum possible profit you can achieve. Yeah, this is a question, but this word not used in this question because the buy and sell you are not using. So we just concerned about the some simulation here. Let's see. Let's understand the question clearly. This is a question. So I will be taking this test case because these test case are very small. It is very difficult to simulate the for any bigger value. So if you can go with this some bigger test cases, so it is very clear to understand how we can doing our writing or logic or you are doing simulation here. You can see, so we are given some integer, right? So this is an array of prices, this is an array of strategy, and you are also given, so the strategy array is only having like -1, 0 and 1. So -1 indicating that you can buy the stock, 0 indicating that is hold the stock, and 1 is indicating that you can sell the stock. But these words are not creating any meaning here, so I will be just erasing it out. So the main idea is we are only concerned with this one of the array, and there is some strategy array, that is we are doing multiplication with these elements. So that's all, and we will find maximum of this. Yeah, we are given some integer k is a even number, right? So let's take k is equal to 6. We are asked that you can select any k size subarray. That is selecting k consecutive numbers is nothing but selecting k size subarray. So what I can do is I will be selecting this subarray, right? You can see, wait a minute. Yeah, so this is a case size array, k is equal to 6. Sorry. Yeah, this is the case size array. So I am taking that k is equal to as 6, right? So you can select any size k size subarray. That means that taking k consecutive elements, and you can set like k by 2 elements. First k by 2 means these three elements. So you can set this element as strategy element, set as 0, and the next k by 2 element, it means second half, you can set the strategy element to be as 1 1 1, and you need to find the maximum sum. So the sum is that how we can get the sum. So the sum is in this case is like something, we are doing p of I into s of I, right? So this is actually we want to find. So this is the profit. So from I is equal to 0 to n. So initially we will be having some of this part, and this is some of this part. So before that I want to just tell you how this window is, like I'm assuming that this is one window, and how it is going to be impacting on the sum of the total sum. Let's see. I will be erasing it out. So this is a window, let's say. So we are setting all the k by 2 element as 0. It means that when you multiply this element, so what you are doing in the sum, like p of I into s of I, right? So this is ultimately when s of I is 0, then you can ultimately having like the sum of this part is 0. And you can see we are only concerned about this part because this part is only contributing to our sum, right? So this is I am taking as window sum, and you can see, yeah, this is a window. When I will be increase my window, not increase. When I will move my window one step forward, you can see. So this is my next window, which is valid window, right? If I will move my window next step, so we can observe here, this this value is subtracted from our window, and this value is added to our window, isn't it? Right? And yeah, it's that's all about this window. And you can you can observe one thing here. So we are only concerned with the k by 2 elements of the k next k by 2 elements, like from k by 2 to k, right? So these are elements which are this part of we are concerned about this part only, because this part is not contributing any value. So what we can do is, you observe one thing. What if I can say that I can remove this window, this part, and I can only taking this as my valid window, so that can be creating impact in my sum, and I will be removing this part, right? I will be removing this part because it is not creating any impact. Yeah, if you can observe, it will be doing same thing. Like if you increase our window, yeah, this is a window. If I will move my window forward, you can see. So you are simply, yeah, this is 3 seconds. Sorry, I will be write clearly here. You can see this is a one window we are working on, right? So if I move my window one step forward, that means that, yeah, it's definitely this one, right? So you are simply subtracting this one from our window and simply adding this element from the window. So you are subtracting this and adding this element into our window, right? And yeah, so I'm saying that we need to just leave this element and we are only concerned with this element, because if you can see, if you can do the summation of this element, they definitely give it 0, because if you multiply it 4 into 0, you will definitely get all this element as 0. And we are only because this element is only creating, because when you multiply it into 1, so the elements remain same. So we are taking this element only. Yeah, let's wait a minute. I will be creating some, I will be explaining it. You can see I am selecting this size window, right? So I want this sum. I will be taking sum one. What I can do is, like, I can take the complete sum initially, because it is, there are two possibilities in our operations. You can perform zero operation. So you can perform zero operation, and you can perform one operation. Not more than that. So in zero operation means we are simply traversing complete array and we are just getting sum. So there might be a cases that if you are not performing operation, then you will get some maximum value, better than this, if you after performing these operations. Let's say, what is this? I am going from I is equal to 0 to n, and I will be simply doing this one, right? Sorry, into s of I, right? Multiplying the prices with the strategy. So that is a, we are doing summation of this and we are storing into our answer. So answer is equal to sum. So what I'm having as of now, I will be having a sum of all this value. Let's say, do one we will do one thing here. What I can do is, now I will be having k is equal to 6 now. So I want to perform operation. So what I can do is, I will be selecting the k is equal to 6 as sub array, like window. This is the, initially I will be take this one, 1 2 3 1 2 3. Yeah, this is a k is equal to 6 as array, right? So what we can do is, we need to subtract all these elements from the window. We want only this element this sum should be remain, and we want to subtract all these elements. What I can do is, I will be traversing from I is equal to 0 to k, and I will be subtracting like sum minus is equal to, what is that, um, p of I into s of I. I will be subtracting this sum, means we are only concerned about this sum for the original sum, and for this we need to modify, right? For modification, we will be do some operation here and we will modify, and we will find the sum of this window. How we can modify it? You can see these elements are definitely 0, because half of the part will get 0. And you can see these elements are modified to 1. And we are only concerned with these elements, right? We will maintain another window as a sum. So that will be having the sum of the windows. So every time we will be updating both these. Let's see, we are not concerned about this. We are subtracted completely this from the sum. We are in the sum, we are only having sum of these values, and in window we need to have sum of this value. You can see this is not we want, but we only want this one. What I can do is, in window I will be adding something like what I will be only traversing from the I is equal to k by 2, because we are only want this sum. So I will be starting from the k by 2 and I will go up to k. What I can do, in my window I will be add something like window plus is equal to p of I, not multiplying anything, because we can say there must to be the strategy element must to be 1. We are set to 1 after modifying. um yeah, so I think you all got I as of now. So we are only updating this sum mind window when we moving our window. So this is the initial configuration of the sum mind window sum. And let's say if I will be move my window, let's say, yeah, I will be erasing all into creating some confusion here. What we can do is, you already seen that. Okay, sorry, I will be erasing this one. Yeah. You already saw that this part is not creating any impact in our sum. So the window part which is having set to 1, this is only the part which is creating some impact into our sum. So what I can do is, I will only concern with this window. When we move our window, we definitely know that we are removing the, let's say this is window. When I will move my window, let's say I will be moving this in my window to one step forward, you can see I will be removing this element, I will be adding one new element. So yeah, you can see when you move our window one step. So let's make the element as, let's check, make this strategy element as, modify the strategy element. This should be 1, this should be 1, this should be 1, and this should be 0, this should be 0, this should be 0. And the sum which we are removing from the window, we should definitely add into our sum, because it needs to be into the sum, and the element which we are adding into our window should be subtracted from our sum. Yeah, you can see this part is not creating any impact, and this part is something which we want to add into our window sum. So you already saw that when the elements in the strategy are 1, only we are adding into our window sum. So it is as same as that I can take this size window as this size. So we don't consider this element because they are already 0. So what I am doing is, you can do like that only, but it's not make sense. Yeah. So the next step is, I will be moving my window to this one step forward, right? So that means that I need to definitely add something like window less is equal to, I need to add this element. So as of now, I will be only having some of this element, and I need to remove this element, right? So it means that it got 0. It means we need to definitely remove that element. So we need to add first this one. That is, yeah. What I can do is, I will be, we came here up to here. It means we are already simulated up to here. So next, what we can do is, we will be traversed from I is equal to k, and I is less than n. We will do I plus plus. So then after these two initial two configurations, we will go to this iteration. We will be start from here. What I can do, when I am moving my window one step forward, means I'm adding one element to my window. That means that window plus is equal to what, p of I. Yeah, p of I, because I'm marking it as 1. I'm modifying the strategy element as 1, so it will doesn't create any impact. Yeah. So another case is that we need to subtract this element. When I'm moving this window to the one step forward, that means the one of the element which is strategy set as 1 is marked, changed to 0. It initially it was 1 in the previous window, right? And in this window it is changed to 0. This means we need to definitely remove this element. That means that, what, how can I remove this element? So let's see. We are actually standing at the I is equal to 6, and k is equal to 6. To remove this third index element, what I can do? I can do I minus k by 2. I will get 3. I is 6. 6 minus 3. That is 3. Yeah, we can do that. So I will be simply subtracting the value that is like this value, which is p of I minus k by 2, right? Yeah, we are done for the window part updation. So as it is, we can what we can do is we need to update the sum also, because this is also when you are moving your window one step, so this is added into your sum. And this sixth index should be subtracted from the actual sum. Initially, what is the actual sum? You can see. Okay, will we remove this one? You can see. So initially this one would be in the window sum, and this one would be the in our actual sum. So when you are moving our window side one step forward, you can see one thing. Observe one thing here. So you are added this part which is already in the this sum. This means base sum is already inside this. So we need to subtract this one, and we need to add this element which is the window out of the element which is out of window. So so if you want to subtract this element, it is very like we are standing on that index only. So what I can do is some, yeah, this is inside these iterations only. So what I can write is sum minus is equal to p of I into s of I, because in sum we are having p of I into s of I as a total sum. And after that we are adding this element. How we can add this element? Let's see. I will be standing on I is equal to 6, k is equal to 6. I want to go from here to there, right? So I want like k minus I. Can I do it? I minus k, not sorry. What I can do is if I can do I minus k, then I can simply say that it is added into our answer. Let's say I will be adding like some place is equal to, yeah, need to, yeah, p of I minus k into p of I minus s of I minus k strategy. You need to multiply that. So this is the complete iteration from the I is equal to k to I is less than n. And this before that we need it, the initial configuration is we need to find the complete base sum. Base sum means the actual sum before performing any operation. And after that we need to remove this window sum from this. We need to remove this window sum, and after that we will be having some window as inside the window we will be having some of the sub array, right? So this is how we can simulate this problem. So it's all about the implementation. If you know a little of sliding window and two pointers, you can do it. Let's see the code once. Yeah, initially I will be taking original as my original sum, that is before performing any zeroth operation, right? So this one would be the zero operation. And I will be maintaining one window sum and one is the original sum. So original sum is the sum which is calculated before operation, and I will be maintaining answer to return the answer. So first I will be going for the initially there is a window, right? So what I can do is first I will be having some of these all these things. I want to remove the window size. That means I want to remove this part. So I will be traversing from I to k. You can see. So I will be traversing from I to k, and I will be subtracting this particular window sum window values window elements from the original sum. So yeah, after that I will be adding k by, I will be traversing from k by 2 to k, and I will be adding the price of I, because this is the operation we did on the window, let's say. So this is the window. Yeah, this is the window. And initially we don't want to care because we already set to 0, and we are only concerned with these elements. So I'm adding this element into our window sum. Yeah, that's the second loop. And after that I will be updating, because there might be some cases that by performing zero operation, we can find the value as a maximum value. After that, you can see, after completion of the first window, we are going for the all the valid windows. You can, there is always, you can see, initially, yeah, I will be show you. Initially we are configuring everything with this particular window. So I will be starting from here. It means that I will be moving my window size to this here, and I can next, in next iteration I will be move my window size to this here. So like that I will be having, and I will be do until the there is a valid window, right? So this is, these are the valid windows. So I will perform like all the operation on the all the windows. Yeah, this is all about, so we already know that we need to update the original, and when the window is moving, it means that we need to subtract the value, like the value which is at the present index. That means that, yeah, I will be tell you, like you could take something 1 2 3 4 5 6 7. So this is one of the valid window. So when I move this window, I need to definitely, yeah, this is, this is added into our window and subtracted from the actual sum. So this is what I am doing here. So, yeah, and I will be adding the first element at the window. When I am moving that window, I need to add that window first element, and after that, this is same as which I am discussed earlier. I will, when I am moving my window, I will be adding the present index, and I will be moving removing that particular element, that is, you can see. So I am already told you that. So you can see, so every, when I am having this window, I will performing operation means this should be something look like this, a strategy array look like this. I want to remove this element, so we don't want to consider about this element, and I want to remove this element, I will be adding this element. You can see this is, and every time I will be updating the answer. This is all about the first question. I hope it's very difficult to understand, but you can try run it on the one or two test cases. You can easily get this one. The second question is XOR after range multiplication queries. You are given an integer nums of length n and 2D integer array queries of size q, where each query is having something L or K V. For each query, you must apply the following operation in order. So in each operation, we can do these things. So the, we need to go from the Li to Ri. Every step, we need to increment our index to the Ki and multiply with the Vi. Yeah, return the bitwise XOR of all the elements in the after processing all queries. So this question is marked medium, but it's very easy question. You can see the constraint. So the constraints are 10 power 3. It means that you can do it brute force. Let's see what the question is given, what is asking. So we are given some a1, a2, a3, a4 as an elements, and we are given q queries, right? In each query, we will be having something what LRVK, right? So, so for every query, you need to traverse from L to R, and when you are traversing from L to R, you need to ensure that, let's say, I will be explaining using the example here. Let's say this is as like 2 to 5, no, 2 to 8. Let's say 2 to 8, right? And V has something 2, K has something 2. So the question is saying that you need to traverse from 2 to 8. It means fourth index, fifth index, sixth index, seventh index, eighth index, and every step you need to skip. If you are initially you are standing at this index, what you can do is you need to modify this array like 0, 1, 2, 3, and so on 4. Let's wait a minute. Yeah, 4 as A5, A6, A7, and so on. This is 5, 6. We are standing at this index. You need to modify in array such that you need to multiply this element. Like this is A3, A3 into what is the multiplication value you are given V. We need to multiply with V. That means V. That is 2. And yeah, we are done with this one. When you are moving to next step, you need to ensure that you need to jump k steps, like 2 steps. You need to skip, like this is 1 step, this is 2 steps. So you need to skip this value, fourth index. So next you are coming here, and let's say 2 3. Yeah, we are at this index. Sorry, we are modified that. So next step, we don't want to go into go to this index. We skip these two elements. K is equal to 2. It means that every time you need to go to the skip the jump to the k steps. Like this is the, sorry, next you can go to this index, you can go to this index. It means that every step you are skipping two jumping two elements, two indexes. And when you are standing at this index, like this is the fourth index, multiplying with the v, again you are here and multiplying with the here. So you can do brute force for every query. You will be go on every query, like for all queries you will be traversing something. Wait a minute. What you can do is for all queries you can do something. You can do each query individual, right? For all queries you will be having L, R, V, K. So from inside the each query I will be traversing from L is equal sorry L to R, and every time I will be increasing my index as L plus is equal to K. Yeah, we can do the perform the operations like, so for each index what I can do, I will be taking array of index. I will be taking I will be starting I is equal to L, I is less than equal to R. And how it is modifying array of I, we are multiplying with the V. Yeah, that's all about this question. You can brute force for each query. So we'll discuss the time complexity also. Let's see the code ones. So I will be traversing all the queries. Inside query we will be having four elements L, R, K, V. For each query I will be traversing from L to R. So every step we need to go jump to the K steps. So for every value at each iteration we need to jump K steps, and I will be simply modifying it. I took long because when you are doing multiplication with the bigger values it may be get overflowed. And after that XOR, we asked to do the XOR of all the elements after processing these queries. So it's very easy. This is like how we can do XOR of the all the elements. So you can see here the time complexity of it be going to be like something. Every we are running the queries queue times, and every query will be running like something. What in the worst case it would be going like n, right? Yeah, 10 power 3, 10 power 10 power 6, n into q into n, I would say. Q into, so there might be some queries which is having something like, let's see. So there might be the queries which is having L as 0 and R as n minus 1, which is last element. In this case, at the worst case, we are traversing from the complete array, so which is n, right? And each query we are traversing, let's say all the queries are 0 to n, then it would be definitely q into n. And this is the simple iteration to find the XOR of all the elements. This is XOR element. I will storing into answer. Into it. So let's see the time complexity for the first question also. Yeah, this is a big O of n. You can see we are running the loop. So this is the first you can big O of n. So this is the view of k times, and this is the view of n times at the worst. At the last, you can see this is the time complexity. View of n is the time complexity of this question, and for the second question, that is n into q. So this is all about the today's content discussion.